You rush into the hospital. A loved one just had surgery, and everything seemed to be just fine. But then something changes. A fever spikes, the doctors look concerned, and tests reveal an infection from a superbug called methicillin-resistant Staph aureus, also known as MRSA. The usual antibiotics do not work, and you're left there hopeless and overwhelmed, thinking, how could this be? Well, this isn't just a rare case. Matter of fact, MRSA's infections affect millions of patients worldwide, leaving doctors with limited to no treatment options. Well, they've also been identified as a top 10 threats according to the World Health Organization. So we may ask ourselves, where does its resistance come from? MRSA's resistance comes from a genetic weapon called the SSC-MEC. It acts like an armor, shielding it even from the strongest antibiotics that we use in practice. Scientists understand how MRSA gains this armor, but what happens when it loses it, and under what conditions? Surprisingly, we do not know much. And this is a very big question that's driving my research. I study a process called the SSC-MEC excision. It is a process by which MRSA sheds this armor. My research explores how environmental stress conditions, like an increase in temperature, nutrient abundance, dry conditions, and even antibiotic exposure, affects this process of SSC-MEC loss. I also look at the various types of MRSAs, whether they're found in community or hospital settings, affects this process of SSC-MEC loss. I use very key genetic and molecular biology tools to measure this. So what have we found? Our data shows that under increased temperature in dry conditions, MRSA tends to shed this armor more frequently, making it more vulnerable to antibiotics. However, under antibiotic exposure alone, it holds on to this armor, making it harder to treat. So these findings raise a very important question. Could we leverage this to help mitigate and treat MRSA infections? This is exactly what we're working on now. Now back to the hospital room. Imagine instead of the doctors telling you we're running out of options, and they say, we know how to treat this. Imagine the relief you and your loved ones would feel. Imagine if we can harness MRSA's own biology to reverse its resistance to antibiotics and save countless lives.